Hi all. In this lecture we will talk about CCA 175 real-time exam scenario 2. Let's see the data description. All the order records are stored in HDFS directory orders_Parquet. Data is in Parquet file format. Now output requirements. Output all the completed orders, that is where order status value is complete. Use JSON format for the output files. Place the result data in HDFS. Order_date should be in format yyyy-MM-dd. Compress the output using GZIP compression, and output should only contain order ID, order date and status. So in this problem statement, first of all we have to understand how to read a Parquet data as a data frame in Spark. On top of that data, we will be applying a filter operation to filter out the records where order_status is complete. We will be changing the order date to yyyy-MM-dd format. After that, we will be applying GZIP compression on top of the data frame and we will save it in HDFS. And output should only contain order ID, order date and order status column. So let's go to the lab and see. Well, orders is equal to spark.read.parquet and providing the path. So this is my orders data. Let's see the data. Orders.show and give me 5 records. Okay, so this is my orders data. What exactly we have to do on top of this data? First of all, we have to filter out the orders where order_status is complete. After that, we have to change the order date, which is in millisecond, and we have to convert this date into this milliseconds into a date. Then we have to select only the column order date, order ID and order status, and we have to save the data in HDFS. Let's say, well, result is equal to orders.filter, and I'm going to apply a filter operation. So for that, I'm going to say order_status is equal to complete. Okay. On top of that, we have to change the order date from millisecond to a date object. So what we have to do is, we'll say dot with column, then providing the column name, which is order_date, and the value is, we can use 2_date here, but for that we have to convert this millisecond into a timestamp. For that we can use from Unix time function, and from Unix time function we have to provide seconds, but we have milliseconds here. So what I'm gonna do is, I'm gonna say the column order_date, divide this value by 1000. So converting the value into seconds and then converting that into a timestamp using from Unix time, and toDate will convert that timestamp into a date. Okay, now after that we have to just save order ID, order date and order status in the HDFS. So what we have to do is, from this data frame we have to say select, and I'm only interested in the columns which is order_ID, order_date and order_status. So this is my result. Let's see some data. So we can say result.show, give me 5 records. So guys, we can see that the order status is complete. Order date is now a date. It's not in milliseconds now. And we are only able to see the 3 columns which we want to save to HDFS. So let's save the data in HDFS now. But before that, we have to apply compression on top of the data. So we will say result.write.option. Inside option, I'll be providing compression. And my compression is GZIP. So After that, because I have to save the data in JSON, so I'll say .json providing the path, and my path is user spark dataset solution. So this is my path. Let's save the data. Okay, so we are able to save a data frame as a JSON. Let's go and validate. Copy the path, go to the other console that we have, HDFS DFS-ls, provide the path, and we can see a JSON file created here with .gz extension. That means we are able to save a data frame as a JSON file in the JSON file format, and we are able to apply GZIP compression on top of that. Now this is one way of solving the problem statement. We can also use a query here. So let's see the second approach. So we have orders data frame with us. Orders.show, give me 5 records. This is my orders data frame. Let's register this data frame as a temp view. Orders.create or replace a temp view. Now let's give it a name. Let's give it a name, orders view. Now what I'm going to do is I'll be using a query now. I'll be saying, well, result is equal to spark.sql, and providing a query here. My query will be select order underscore ID, and then order. We have to convert this millisecond order date into a date using the specified format. So I'm going to say toDate. Inside toDate, I have to say from Unix time and passing order date. Because my date is in milliseconds, so I have to convert it into second by dividing by 1000 and giving it a column name order underscore date. And finally, we need order status. Now, from orders view, orders underscore view, where order status is equal to complete. And this is end of my query. Okay. Now we got the data frame result. Let's see the data. Result dot show. Show me 5 records. Now this is my data frame. Again, we will be saving this data frame in HDFS in JSON format like we did earlier. But because the path already exists there, so I'll be using the save mode. Let's see that. Result dot write dot, and we have to apply compression on top of the data as well. So I'm going to say result dot write dot option and providing the compression, and my compression is GZIP. Okay. Now I'll be saying dot mode, and my mode is save mode dot overwrite, and then I'll be saving the data using .json providing the path. So my path is /user spark /dataset scenario 2 and result solution. Okay, let's save the data. Okay, we are able to do that. Now let's validate again. Let's go back to the other console that we have, and we will be doing HDFS DFS-ls and providing the path. We should be able to see a JSON file with .gz extension. So this is my JSON file with .gz extension. So these are the two different ways to solve the problem statement. Thank you.